Welcome to Spring LIB.
This is the answer to Chapter 19, problem number 9 from the Smith Organic Chemistry textbook. And this problem asks us about this prostaglandin PGF2 alpha. And we're asked several things about this molecule. So we're asked how many tetrahedral stereogenic centers does this molecule contain? We're asked to draw its enantiomer. We're asked how many of its double bonds can exhibit cis-trans isomerism. And then we're asked how many possible stereoisomers are there for this molecule. And so there are 5 stereocenters here. So they are going to be these ones that I'm going to arrow. And basically, it's anywhere that you see stereochemistry drawn in. So these 5 carbons are stereocenters. Okay, so to draw the enantiomer, what we're going to do is just flip the stereochemistry at those stereocenters. So dashes become wedges, wedges become dashes, and we'll just do that for every single one, and that's going to be our enantiomer. So okay, so there is the enantiomer of this molecule. So what else are we asked? Okay, so we said there were 5 stereocenters. So I have arrowed them in red. There's 5 of them. The next question is how many of its double bonds can exhibit cis-trans isomerism? So there are 2 double bonds, and the answer is both of them. So both double bonds. Okay, and then okay, and so considering the double bonds and the stereocenters, how many isomers are possible? And so the way to solve that is to say, well, we have 5 stereocenters and 2 double bonds, so 7 total possible sites for isomers. And so to arrive at that answer, we're going to take 2 and raise it to the power of 7. And that is going to be equal to 128. So there are 128 isomers. And I suppose I should say 128 stereoisomers. Okay, so there are 128 possible stereoisomers here. And again, we got that by adding up the 5 tetrahedral stereocenters and the 2 double bonds that can isomerize, and then raising 2 to that number 7 that equals. Yeah. Okay, and so that's the answer here. Again, we got the enantiomer just by flipping all of the stereocenters in the original molecule, and there were 5 of those stereocenters. And so that's the answer to Chapter 19, problem number 9.